Hello everyone, welcome to this video. In this video, we are going to solve the questions from engineering mathematics, which were asked in GATE Aerospace Engineering 2008 paper. And from this slide, we get idea that there were 13 questions, out of which 3 questions were asked for 1 mark, and rest of the 10 questions were for 2 marks. So let's start solving these questions one by one. Yeah, coming towards the first question, here they have given f of x, which is sine of x when x value is less than 0. The value of function is 0 when x is equal to 0, and the value of function is 3x cubed when x is greater than 0. So if you roughly want to draw it, it will look something like this. X f of x. So after 0, the function is behaving like a cubic parabola. So I'll draw a cubic parabola here. And at 0, the value of function is 0. And below 0, the value of function behaves like a sine function. So maybe something like this. Okay. So this is just to give you overall idea how actually the given function looks like. Looking into this figure, we can clearly see that the function is continuous, but now we have to check whether it is differentiable or not. Okay, so we'll try to prove it mathematically about the continuity and differentiability. Whenever this kind of question comes, always try to do the differentiability check first, because whenever function is differentiable, it must be continuous. Okay, so it will save your time to do the continuity check, and you can do the continuity check only in those cases whenever you find your function is not differentiable. Okay, so if you go in this reverse order, it will save your time from exam point of view. So let's first start with the differentiability check. So when we say the function is differentiable, when the right hand derivative and left hand derivative is equal to the actual derivative at that point, then only we'll say that the function is differentiable at that point. So all the options here are related to the x is equal to 0. So our point of interest is x is equal to 0. So we'll calculate left hand derivative, right hand derivative, and the actual value of derivative at that point. Okay, so left hand derivative is limit x tends to a from the negative side, f of x minus f of a divided by x minus a. So we are approaching the point a here, which is 0 in this case, from the negative side. So this is the general formula, and if we want to write in terms of the given values, it will look something like this. Limit x tends to 0 from negative side, f of x is sine of x minus f of 0 is 0, and x minus 0. So what we are getting here, we are getting limit x tends to 0 from negative side, sine of x by x. Okay, limit x tends to 0, sine of x by x is 1. So this is what we got as left hand derivative. Now let's try to calculate the right hand derivative. Limit x tends to a from positive side, f of x minus f of a divided by x minus a. This is the generalized formula. And now if you put a is equal to 0, so limit x tends to 0 from positive side, f of x in this case is different. It is 3x square, 3x cube minus 0 divided by x minus 0. And if you solve it, you will end up with limit x tends to 0, 3x square. And now if you put the value of x is equal to 0, you'll end up with 0 answer here. And what is the f dash of a? F of a is 0, so f dash of a is also 0. So we can clearly see here the left hand derivative and right hand derivative are not equal. Okay, so this condition, left hand derivative should be equal to right hand derivative should be equal to f dash of a, then only the function is differentiable, but it is not in this case. Hence, this function is not differentiable. Okay, so what are the options? The first option is there and the last option is there. So we have to first check about the now continuity. Okay, so now we have checked that is not differentiable. If it is differentiable, then we could have said like it is continuous as well as differentiable, because all differentiable functions are continuous. But in this case, it is not differentiable, so we have to do the continuity check. Okay, so what is continuity check? Limit x tends to a from negative side f of x, if it is equal to limit x tends to a from positive side f of x, and if it is equal to f of a, then we say the function is continuous. So let's try to calculate all these three values. What is limit x tends to a from negative side? Our function is sine of x, and the value of a is 0 here. So if you put x is equal to 0, you'll end up with a 0 value. Similarly, if limit x tends to 0 from positive side, function is 3x cube, and now if you put x is equal to 0, you'll end up with a 0 value. And we also know f of 0 is 0. So looking into all these three values, we can clearly say that this equation number 1 is satisfying, and the given function is hence continuous. Okay, so this is the continuity check, and whatever we have done in the first slide was differentiability check. Our differentiability check got failed, but continuity check is passed. So the correct option here in this case is option D, that is the function is continuous but not differentiable at x is equal to 0. Okay, so let's go to the next question. The second question is about the product of eigenvalues of this matrix. Okay, so there is a simple rule that product of eigenvalues is equal to the determinant of matrix. So it is a 3 cross 3 matrix. So we'll have 3 eigenvalues, lambda 1, lambda 2, and lambda 3. And if you multiply it, it should be equal to the determinant of matrix. Okay, so you should know this trick. Otherwise, you may have to calculate first eigenvalues and then multiply, and it will take a lot of time. Okay, there is one more rule related to the eigenvalues, just for your information. Sum of eigenvalues equal to the trace of the matrix. Okay, and this one is product of eigenvalues equal to the determinant of a matrix. Okay, so these two rules are very important, and it will help you to solve the questions easily. So let's try to calculate the determinant in this case. So 1 0 1 0 2 1 1 1 minus 3. If you take a determinant in this case, it would be 1 into minus 6 minus 1 minus 0 plus 1 into 0 minus 2. So if you further solve it, it is -6 minus 1 is -7, -0, you can ignore it, and then -2. So it is -9. So we can say that option D is correct in this case. Okay, it was pretty simple. Coming towards next question. Yeah. So this is again a 1 mark question. So first, the last two which we have just solved, those were also 1 mark questions. Okay. So here the question is, which of the following equation is a linear ordinary differential equation? Okay. So we have to figure it out of these 4 options, which is the linear ordinary differential equation. So I would like to give a definition here, which will help us to easily figure it out which of this is the correct option. Okay, whenever we say the linear ordinary differential equation, in that equation, the dependent variable, and its derivatives should be of first degree only, and there should be no product of them. There should be no product of them. Okay, so just by understanding this definition, we can clearly say in the first case, we can clearly see y square is there. Okay, so it's not a first degree, so we can ignore this. Coming towards second question, second option here, y into dy by dx is there. So the dependent variable and its derivatives are in multiplication, and this statement says there should be no product of them, so we can also ignore it. Okay, what about the third case? In third case, yeah, here looks like everything is getting satisfied. We don't have the higher degree of dependent variable or its derivatives, and they are not in multiplication also, so we can say that option C is correct in this case. Okay, option D is again wrong because we can say dy by dx whole square is there, so it is again not a first degree, so that's why option D is again wrong here. Okay, so coming towards the next question. So from here we can say that there will be a little increase in the difficulty level because these are now 2 marks questions. So let's try to solve them. So what this question says, they have given a function in terms of x, y, and z, and that is equal to 1/2 x square y square z square, and it satisfies, and they have given us the 4 options. Okay, just by looking into this option, we can clearly see, we can figure out the actual solution, because you don't have to solve it even, because if you know the properties of the vector, if you know the properties of vector, then this is pretty simple question. Okay, so I will just give you the important notes in this case. So curl of a gradient of f, gradient of f is 0. Okay, and divergence of curl of a vector is 0. Okay, so if you know this, these are the basic properties, and out of this we can clearly see the option C is there. which is satisfying one of these property, and we can directly tick it. But just for but I'll solve it to make sure that we are satisfying this property. So I j k. Okay, so first of all, let's calculate gradient of f. Gradient of f is, in this case, del dot f. Okay, so you have to operate, you have to do operate a del operator on this scalar function, and you will end up with, I'll directly write here, xy square z square I plus y x square z square j plus x square y square zk. Okay, so this is the gradient of f, and now we will take the curl of it. So how we'll calculate the curl? It's a cross product. Okay, so you'll operate you'll perform a del operation, but with a cross product. So it will be I j k dou by dou x dou by dou y dou by dou z x y square z square y x square z square and x square y square z. Okay, if you take a determinant of it and solve, I times dou by dou I of this term, which is 2x square yz, okay, minus dou by dou z of this term, which is again 2x square yz. Okay, similarly the next term will be, I'll directly write here, 2xzy square minus 2xzy square, and the last term would be 2xy square z minus 2xy square z. Okay, no, it is 2xy z square and 2xy z square. Okay, so now we can clearly see that all these terms will cancel out with each other. Okay, and it is 0i plus 0j plus 0k, so it's a null vector. Okay, it's a null vector, and we can say that curl of a gradient of the function is 0. Okay, but if you know this theorem, it will save your time and you can directly choose the option. Okay, coming towards the next question, this is again from the vector calculus. Here they have given us the three vectors p, q, and r, and they're asking us out of this 4 options which is the true. So so let's try to look into it. So we can clearly see there are many cross products here. So I would like to tell you one property related to the cross product. So if you have a p bar and it is doing a cross product with q bar cross r bar, then we can actually write it as p dot r into q minus p dot q into r. Okay, so this makes it simpler. So if you look into this last option, why I'm doing this, because we can If we convert the cross product into the dot products, then things will become simple to analyze, and we will go to the solution easily. So so if you look into the fourth option, which is for which the first term I have already written, the second term is Q bar cross R bar cross P bar plus R bar cross P bar cross Q bar. Okay, so let's check whether it is satisfying the equal to 0 criteria or not. So the second term would be like Q dot P into R minus Q dot R into P, and the last term would be R dot Q into P minus R dot P into Q. Okay, so if you focus in this all 6 terms, okay, so basically 3 major terms, and in that we have 2 terms, so total 6 terms are there. They will cancel out with each other. Okay, so PR into Q and RP into Q, so this term will get cancelled out with this. Okay, because if you take a dot product of A and B, it is equal to the dot product of B and A. So similarly, the other options, PQ, P dot Q into R and Q dot P into R will get cancelled out with each other. And similarly, the remaining 2 terms will also get cancelled out with each other, and you will end up with a 0 answer. Okay, hence the option D is correct in this case. Why option A, B, C is incorrect? Because why I have not tried that first? Just by looking into it, you will realize that the first option is a cross product. Okay, so it's a P cross Q and then Q cross R and R cross P. So it will end up with like 3 different vectors, and addition of all of them may not be not necessarily equal to 0. The second option here is again we got a dot product of P and Q. So even if you assume any random, let's say P bar is equal to P1 I plus P2J plus P3K, and similarly the Q bar is Q1I plus Q2J plus Q3K, and if you first take a dot product P bar dot Q bar, you will end up with P1 Q1 plus P2 Q2 and P3 Q3, and then you will multiply with R bar. So all the terms are positive here. Okay, and you may not cancel out these terms and you'll not end up with a 0 answer. Okay, it's not necessarily true. So the out of this only option which looks correct is option D. Even in option C, it's a combination of dot and cross. Even if you simplify it, let's say the first term of the third option is P bar dot Q bar cross R bar. You may write it as P bar cross Q bar dot R bar, but you will end up with the similar terms, and on further calculation of it, we'll realize that it is not necessarily equal to 0. Okay, so as I have shown, the option D is correct here in this case. Okay, coming towards the next question. This question is related to the line integral, where they have asked us to find the value of integral 1 upon 2 pi line integral x dy minus y dx taken anticlockwise along the circle of a unit radius. Okay, so let's try to solve it. So in this question, you can clearly see this looks in the form of m dx plus n dy. So the hint for this question is to apply the Gauss theorem to convert the line integral into the region integral. So let's try to look into it. A line integral m dx plus n dy is equal to a region integral r, derivative of n with respect to x minus derivative of m with respect to y. Okay, dx dy. Okay, this is the Gauss theorem to convert the line integral into the region or area integral. So now applying this theorem, let's try to simplify this problem, where our region of interest is the circle with unit radius. Okay, so now what is n here? The coefficient of dy is n, which is x in this case. So derivative of n with respect to x is 1, and derivative of m with respect to y is -1. So you will end up with double integration 1 minus -1, which is 1 plus 1, which is 2. So I'll directly write here 2, because derivative of n with respect to x is equal to 1, and derivative of m with respect to y is -1. Okay, so considering this, we can write it as a 2 dx dy, and with the limits in terms of x and y, from x1 to x2 and y1 to y2. But as you see this problem, this will be easy if you solve this problem by in terms of polar coordinate system. So I would convert this Cartesian coordinate system into the polar by multiplying the Jacobian, which is r in this case, and dr d theta, and limit of r is 0 to 1, and theta will vary from 0 to 2 pi. Okay, and in this case we have 1 upon 2 pi already outside the bracket. So let's try to simplify it. So 1 upon 2 pi as it is, or this 2 and 2 will get cancelled out with each other. So I'll just write 1 upon pi. Integration of r is r square by 2. Limit is 0 to 1. And integration of theta is integration of 1 with respect to theta is d theta is theta, and limit is 0 to 2 pi. So you'll end up with theta 0 to 2 pi, and if you solve it further and putting the limits, 1 upon pi into r is equal to 1, if you put it is 1 upon 2, and if you put theta is equal to 2 pi, it is 2 pi. So 2 pi will get cancelled out with each other, and you'll end up with answer as 1. So option B is correct in this case. Okay, so major trick here is to apply the Gauss theorem to convert the line integral into the region integral. So this is the shaded region, is the region which is bounded inside the closed line or closed loop, we can say, because whenever they are using this integration symbol and a circle inside the integration symbol, it means it's a closed curve. Okay, so let's call it as C, and R is the region which is bounded inside this curve C. Okay, so this is the main trick to solve this problem, and after that we are converting the Cartesian system into the polar to make it easier to solve. Okay. So coming towards the next question. So this question is about the differential equation, and they're asking us the solution of this differential equation, which is d2y by dx square plus 2dy by dx plus y equal to 0. So let's try to write it in terms of capital D. We know that we can write d by dx as capital D. So it is d square plus 2d plus 1 times y equal to 0. And now we have to treat this as a algebraic equation and solve it. So it will look like d square plus 2d plus 1 equal to 0. So this is a d plus 1 whole square, correct? D plus 1 whole square is d square plus 1 square plus 2 times d into 1. So this is equal to 0. So if you solve this, you will get d is equal to minus 1 comma minus 1. So here we got real and repeated roots. Okay, and the current equation is homogeneous differential equation, and whenever we have the homogeneous differential equation, the solution is only the CF part. So I can directly write y is equal to the complementary function in this case, and the complementary function is for the real and repeated roots is c1 plus c2x e to the power minus x. Okay, so if I multiply e to the power x inside, it is c1 e to the power minus x plus c2 e to the power c2x e to the power minus x. Okay, so if you assume c1 and c2 as 1, so you will realize that out of these all options, the first option is correct in this case. Okay, yeah, e to the power minus x, assuming c1 and c2 as 1, or if you ignore it, you will end up with e to the power minus x plus x e to the power minus x. Option A is correct. Okay, coming towards the next question. So this question is again from the differential equations, where they have given us two differential equations. One is in the form of f and x, and other one is in the form of g and t. So in first differential equation, the f is the dependent variable and x is independent variable, whereas in second, g is the dependent variable and t is the independent variable. And they're asking us that the function u, which is depend on x as well as t, because it is equal to f of x into g of t, then that function should satisfy the out of these four, it should satisfy one differential equation. So let's try to prove it. So I'll take a first differential equation here, d2f divided by dx square plus p square f equal to 0. Okay, so if I solve it, I can write it as d square plus p square times f equal to 0. And then we can say d square equal to minus p square. Hence, d is equal to plus or minus p times I. Okay, so here we got complex roots, and hence the f of x in this case is equal to, as this is a homogeneous differential equation, so only complementary function itself is the solution. So it is c1 cos of px plus c2 sine of px. Okay, because it's same as saying 0 plus or minus pi. So e to the power 0 is 1. So that term I have ignored and directly written the final answer. So similarly, for the second differential equation, which is dg by dt plus c square p square g equal to 0, we can say that d plus c square p square times g equal to 0, and we can say that d is equal to minus c square p square. Okay, and hence the g of t will be equal to e to the power minus c square p square t. Okay, so we got f of x now and we got g of t now. Okay, so these two things we already know now, and now the question is our function, which is in terms of multiplication of f of x into g of t, should satisfy one equation out of these four. So let's try to take the different derivatives of this f of x and g of t. So let's take first derivative of this g of t. So let me write it here again. F of x is equal to c1 cos of px plus c2 sine of px, and g of t is equal to e to the power minus c square p square t. Okay, so now our u of x comma t, which is equal to f of x into g of t, will be equal to e to the power minus c square p square t into c1 cos of px plus c2 sine of px. Okay, so let's take a first derivative of with respect to t, which is dou u by dou t, and that is equal to minus c square p square e to the power minus c square p square t, and the rest of the term will remain as it is, which is in terms of x, so we have to treat it as a constant. Okay, and now if you take a differentiation with respect to x, how it will look like. Differentiation with respect to x is e to the power minus c square p square t, and here we'll get c1. The first differentiation is sine of px minus sine of px into p, so we'll say it as a minus c1p sine of px plus c2p cos of px. And if you take a differentiation again and dou 2u by dou x square, it will be minus c square e to the power minus c square p square t, and this will be differentiation of sine of px is cos of px into p, so this is p into p is p square, and which will get again in the next term, so we'll take it outside, minus p square. So I will write it as c1 cos of px plus c2 sine of px. So if you compare this equation number 1 and equation number 2, you will realize that they are very similar. So you can say dou u by dou t, okay, dou u by dou t multiply by, okay, c square is equal to dou 2u by dou x square. Okay, only difference in these two equations is we don't have c square term in the second equation, and which we have in the first. So okay, so I should write it like this. Okay, dou u by dou t is equal to c square times dou 2u by dou x square. Okay, so let's look for this option. Yeah, so the option B is correct in this case. Okay, so this was a little big compared to others. Coming towards next question. Here, this is from the linear algebra. where they are asking us um, the solution of the set of simultaneous equations which are already given. Looking into this data, we can clearly say that this is in the form of Ax equal to B, which is a non-homogeneous system of equations. So whenever we have Ax equal to B, and we have to conclude on the type of the solution, we have to first check the rank of the matrix. Okay, so first of all, we'll make a augmented matrix AB, and rank of augmented matrix AB, if it is equal to rank of A, then we'll say it as a consistent. And if rank of AB is not equal to rank of A, then we can say it as inconsistent. Okay, when the system of equation is inconsistent, we say no solution. Okay, then those equations will not have any solution. But if they are consistent, then depending on the rank, we will say we'll have either unique solution or infinite number of solution. So if rank of matrix AB equal to rank of A and it is equal to number of unknowns, then we'll get a unique solution. Okay, and if it is not the case, if it is not equal to n, in that case we'll get infinite number of solution. Okay, so this table will help us, or this chart will help us to answer this question easily. So let's make an augmented matrix here AB. So first of all, I will write AB A matrix 1 1 2 1 0 1 0 1 1, and then the dotted line 1 minus 1 0. Okay, and now let's try to perform the operation, try to convert this matrix into the echelon form. So I'll perform the first operation, R2 is equal to R2 minus R1, because we want to make this term as 0. So the first row will remain same. Second row will become 1 minus 1 is 0. 0 minus 1 is minus 1. 1 minus 2 is minus 1. Minus 1 minus 1 is minus 2. And the last row will again remain same, because we have not yet performed operation on the last row. Now let's make this term 0. To make this term 0, what we have to do? We have to add R3 plus R2. Okay. So if you perform the operation, how it will look like? First row remains as it is 1 1 2. Second row remains as it is 0 minus 1 minus 1. Third row will become 0 0 0. And the other part is B part here is 1 minus 2 and minus 2. So the left hand part of this dotted line is matrix A, and the overall matrix is matrix AB. So if you just focus on matrix A here, this part, we can clearly say here rank is 2, and the rank of overall matrix is 3. Hence, it is coming under the second case of inconsistency. Okay, this inconsistent case, which is where the rank of AB is not equal to rank of A. Hence, for this set of equation, we'll say it will not have solution. So option A is correct in this case. It means no solution. Okay. Coming towards the next question. This is related to the maxima and minima, where they have given us the function f of x, which is equal to x square minus 5x plus 6. And we are supposed to find out the value at which where it is minima or maxima. So let's try to find out the f dash of x. F dash of x is 2x minus 5. And whenever we calculate the minima and maxima, we equate the derivative with 0 and get the value of the x. So in this case, x is equal to 5 by 2, okay, which is 2.5. So again, if you double differentiate this function, double dash of x, you will get 2, and this is greater than 0. As it is greater than 0, we can say at x is equal to 2.5, it is a minima. Function is having the minimum value, or x is equal to 2.5 is a minima. Okay. So out of this, which option is correct? So first option is for the x is equal to 2, so we have to ignore it. Second option is maximum value at 2.5, which is again wrong. And the option C and D are related to some range from 2 to 2.5 and 2.5 to 3. So looking into these two options, we can clearly say that we are getting minima value at 2.5. Okay, so let's say this is a 2.5 value, and at this 2.5 we are getting a function value which is minimum. So after this point, our function should value of the function should increase. Okay, and below this or before this point, our value of the function should decrease, and only option D is satisfying that criteria. Hence the correct option for this question is option D. Okay, coming towards the next question. This is from the Laplace transform. Let y of s, capital Y of s, denote the Laplace transform of y of t of the function y of t equal to cos of hyperbolic of at and sine of at. So let's write y of t. It is cos hyperbolic of at into sine of at, and the Laplace transform of y of t is capital Y of s, which is given. Okay, so out of these four options, which is correct, we have to identify. So if you look into these options, we can clearly see that these options are related to the some properties of Laplace transform. So the first property which they are using here is Laplace transform of derivative. Okay. So what is Laplace transform of derivative? Let's say Laplace transform of dy by dt. Okay, or you can write it as Laplace transform of y dash of t is equal to s into Laplace transform of y of t, which is capital Y of s in this case, minus y of 0. Okay, so in this case, if you put t is equal to 0, the sine 0 is 0. So anyway, this will become 0, and you will end up with s into y of s. Okay. The second property which is used in this options is multiplication by t property. Laplace transform of t into y of t is equal to, we know, whenever we are multiplying with a t, we have to use the formula. So generalized formula is t raised to the power n into y of t is minus 1 raised to the power n times differentiation of the Laplace transform of y of t. So I can say here as capital Y of s. Okay. So in this case, the n is equal to 1. So Laplace transform of t into y of t would be equal to minus 1 raised to the power 1 into d by ds of capital Y of x. Okay. So we can write it as minus dy by ds. Okay. So looking into the options, we can clearly say that option B is correct, because you can clearly see here, this is exactly matching with the solutions which we got. Okay, so option B is correct for this question. Yeah, coming towards this these two questions. So these question number 76 and 77 are linked question, and they are from the numerical methods topic, especially from the Simpson's rule. Whenever they say Simpson's rule, we have to assume it as they are asking about the Simpson's 1/3 rule. Okay, so the question is, which of the following gives the correct formula for Simpson's rule for approximating the integral a to b f of x dx in the interval a to b? Okay, so let's look into the options. Yeah. So the generalized formula of Simpson's 1/3 rule is integration a to b f of x dx, which is equal to h by 3, where h is the step size, into f of x naught plus f of xn plus 4 times f of x1 plus f of x2, sorry, f of x3 plus f of x5, all odd terms till f of xn minus 1, then plus 2 times all even terms f of x2 plus f of x4 plus f of x6 till f of xn minus 2. Okay, so this is how the generalized formula for the Newton for the Simpson's 1/3 rule will look like. And now coming towards this problem, so we got an interval from a to b. Okay, so as we can clearly see, there are multiple terms. There are specifically 3 terms in this. It means this interval is divided into 2 groups. So the center point here would be a plus b by 2. Okay, though it's not given in this question that there are 2 steps or how many number of intervals are there, but looking at the options, we can clearly see that each option is consisting of like of the 3 terms. So you can break it from here and you will realize it. Okay, so this is our x naught, this is our xn, which is equal to x2 as well, and this is our x1. So with this, try to solve this question. In this case, the value of h is equal to b minus a divided by 2, because we got 2 intervals here, a to a plus b by 2 and a plus b by 2 to b. Okay, so we got 2 intervals, so I'm dividing with 2, and that is what you can even see, which is common in all these 4 options. So in first option, b minus a by 2, second also b minus a by 2, and so on. So that is why even though it's not mentioned in the question, we should understand that there are 2 intervals. Okay, so with this, if you try to rewrite the equation number 1, it will be b minus a divided by 2 into f of a plus, so here we should divide by 3 as well. Okay, because it's h by 3, f of a plus f of b plus 4 times f of a plus b divided by 2. And if you bring this 3 inside the bracket, you can write it like this as well. Okay, so now if you compare with the options, we can clearly say that the option C is correct in this case. Okay, just yeah, it's exactly matching b minus a by 2 f of a plus f of b divided by 3 plus 4 by 3 times f of a plus b by 2. Okay, so we got the option, correct option here. Coming towards the next question, which is again based on the same, again linked with the previous question. Here they are asking us the percentage error with respect to the exact solution in estimation of integral 0 to 1 x cubed dx. Okay, if you solve this, it is x raised to the power 4 divided by 4. Putting the limit 0 to 1, we'll end up with 1 by 4 answer. Okay, and considering this equation 2, if you calculate the value of integral, how it will look like? It will look like as a b minus a by 2. So here b is 1, a is 0. So b minus a by 2 is 1 by 2 times f of a plus f of b divided by 3. Okay, sorry, f of a is 0, f of b is 1. So 0 plus 1 by 3 plus 4 by 3 times f of a plus b divided by 2. So it is 0 plus 1 divided by 2 is 0.5 and 0.5 cube. 0.5 divided by 2 whole cube. Okay. It is a plus b divided by 2. So yeah, I think it is just 0.5 whole cube. Okay. 0.5 can be written as 1 upon 2 as well. So 1 upon 2 whole cube. And now if you further simplify it, what we'll get? 1 by 2 into 1 by 3 plus 4 by 3 into 1 by 8. So it will be 4 ones are 4 twos are, and if you further simplify, it is 1 by 2. This can be written as 2 by 6 plus 1 by 6. So it is 3 by 6 again. So 1 by 2 into 3 by 6. 3 by 6 means again 1 by 2, and it is 1 by 4. So if you compare the equation number 1, so if you compare the equations 1 and 2, we can clearly say that the value which we have calculated by the exact solution method, okay, and with the numerical method of Simpson's 1/3 rule is exactly matching here. Hence the percentage error in this case would be 0. Okay, hence option D is correct in this case. Okay, so that's all from this paper. Thank you all for watching this video. Bye.